Hello students, welcome to your channel Parivartan Physics. Dear students, this is the series of videos where we are learning KCET PYQs of last 5 years, that is from 2021 to 2025. So first two chapters we have already completed from second PUC, electric charges and fields as well as electric potential and capacitance. In this video we are going to learn the KCET PYQs of last 5 years from current electricity. Dear students, if you want the questions before 2021, I mean beyond this, then there is one more video I have already uploaded. In that I have solved the questions before 2021. You can watch that also in the same playlist. You will find it, right? Other than that, I have also started a series of videos where we are learning in-depth concepts for all the concept shortcuts and techniques for KCET 2026. So that playlist is also getting updated. So you can watch the videos there for learning all the concepts which are required to crack KCET 2026, right? Okay, without making any delay, let us begin the video then. See, this is from KCET 2025. So read the question. Here, the graph between variation of resistance of a metal wire as a function of its diameter, keeping other parameters like length and temperature constant. So diameter and resistance, relation between diameter and resistance they are asking. See, we know very well, resistance is equal to rho into L divided by A, rho into L divided by A, correct? So here I can write resistance is equal to rho into L is also constant, temperature is also constant. So area means I can take it as pi r square, right? And what is diameter? Diameter means it is 2 times of radius. So 2 times of radius square. It indicates that resistance is inversely proportional to diameter square, right? So inversely proportional to diameter square adandamele, it has to be a rectangular hyperbola. Hence, here the decreasing graph. Nodri, ivantu ಎರಡು increasing graphs adava, ivantu eliminate ಆಗ್ತವೆ. Decreasing graph ಅಂದ್ರೆ ಎರಡು ಅದಾವೆ. It would have been straight line if it is r is inversely proportional to d, but it is r is inversely proportional to d square, so option D is correct. Okay, let us go to the next question. Given a current carrying wire of non-uniform cross section, which of the following is constant throughout the length of the wire? Non-uniform wire ittapa antandre, first thing idu concept olaga ನಾವು ಕಲ್ತಿದೀವಿ. I will tell you this. Even if the cross sectional area of the wire is different, the current will be same. Right? So ignore it. Illi area namagu bere ada, illi area namagu bere ada. Here area is different, right? So current in all these things will be same. Illu current ashte irtatri, illu current ashte irtatri, illu current ashte irtatri. Same current will not change. What it will change? Speed will change. Ill speed bere irtatri, ill speed bere irtatri, ill speed bere irtatri. Where area is more, A1 is greater, A2 is less than that, A3 is less than that. Current will be same everywhere. I1 is equal to I2 is equal to I3 is equal to I. Speeds will be different. Here speed will be less, here speed will be more than that, here speed will be more than that. So speeds change ಆಗ್ತವೆ, current same ಇರ್ತದೆ, right? So only current remains same, right? ಅವ್ರು ನಮಗೇನು ಕೇಳ್ತಾರೆ, which of the following is constant throughout the length of the wire? So which is constant? Current is constant, only current, right? This is also from 2025. We'll go for the next question. This also from 2025. See, the variation of resistivity to absolute temperature for 3 different materials X, Y and Z are shown in the graph below. Identify the materials X, Y and Z. See, ಈಗ ನೀವಿಲ್ಲಿ ಗ್ರಾಫ್ಸ್ ನೋಡ್ಕೊಂಡ್ರೆ, if you see the graph, first X graph nodri. X graph is increasing graph. With the temperature, resistivity is increasing, right? So temperature is also increasing and resistivity is also increasing, and it is a curve, right? And Y graph, temperature is also increasing, resistivity is also increasing, it is a straight line, right? Z graph, temperature is increasing, resistivity is decreasing, correct? So ille ನೀವು ಇದರ ಮೇಲೆ observe ಮಾಡಬಹುದು. We know very well in metals, I mean in conductors, by increasing temperature, resistance and resistivity will increase. And in semiconductors, by increasing temperature, resistivity decreases, conductivity increases. This is what happens in semiconductors. So it is clear that Z graph is for semiconductors and X graph is for conductors, right? Andmele Y straight line ಏನದ, this indicates for alloys. ಇದು ನಮಗೆ alloys ನ indicate ಮಾಡ್ತದೆ. ಈ ಗ್ರಾಫ್ಸ್ ಗಳನ್ನು ನೋಡ್ಕೊಂಡಿದ್ದೀವಿ ಕರೆಂಟ್ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಥಿಯರಿ ಒಳಗೆ, right? So X is, see, X graph indicates conductor. So X under copper is a conductor. Y nichrome is an alloy. Yes, Y is alloy. Z semiconductor. Yes, Z is for semiconductor. Hence option A is correct, right? So metals ಒಳಗ by increasing temperature, resistance and resistivity increases. Alloys ಒಳಗ almost it will be independent of temperature, but a light increment happens. And in conductors, and in semiconductors, By increasing temperature, number of free electrons will become more, hence conductivity will increase and resistivity will decrease, right? That is what happens. Okay, next question. Two cells of EMF E1 and E2 are and internal resistance R1 and R2 respectively are connected in parallel as shown in the figure. The equivalent EMF of the combination is E equivalent. Then they are asking us about E equivalent. Okay, see, E equivalent, you remember, ಇಲ್ಲಿ ಏನ್ ನಮಗೆ E equivalent ಇರ್ತದ್ರಿ, this always lies in between the EMF of the two cells. After the effective EMF ನಮಗೆ ಏನಿರ್ತದಲ್ಲ, it will be, its value will be in between E1 and E2. ಇದನ್ನ ಬಿಟ್ಕೊಡಿ, standard value, standard thing ಅದ, you have to remember that. E equivalent lies in between the EMF of the minimum and maximum EMF of the cells connected in parallel. And it will be close to the EMF which is smaller. It will be close to the EMF which is smaller. So here we are writing EQ is less than E1 and less than E2. So ಇವೆರಡು ತರದ middle value ಒಳಗೆ ಇರ್ತದೆ. ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ಅವರು ನಮಗೆ ಮೆನ್ಷನ್ ಮಾಡಿದ್ದಾರೆ E2 is greater than E1 and R2 is greater than R1 ಅಂತ. Right? So E2 is greater, E1 is smaller. Hence E equivalent has to be close to E1. It has to be close to E1, right? Near to E1. So which option will be correct? Option A will be correct. This is from 2025. Okay, let us move on to the next question. In the following circuit, the terminal voltage across the cell is, terminal voltage across the cell they are asking. So let us calculate the terminal voltage here. First, very first thing is what they have given. Okay, here they have given 3.9 watt, 3.9 watt, but it is not watt actually. It has to be ohm, right? The ohm irbekata, it is not watt. Okay, let us calculate current then. So we can calculate current I is equal to, so let us calculate the current. Current I is equal to, we know the formula, I is equal to E divided by R plus R. So how much is E? E is to external resistance yesterday. External resistance is 3.9. Internal resistance is 0.1. Correct? So this is 2 divided by 4, which is equal to 1 by 2. Hence it is 0.5 ampere. So this much is the current. They are asking us how much is the terminal potential difference of the cell. So terminal potential difference of the cell will be V is equal to E minus IR. This we know. So how much is E? E is 2. How much is I? I is 1 by 2 half. How much is R? R is 0.1. Right? 0.1. So I can write it like this. 2 into 2 minus half means it is 0.5 into 10 to the power minus 1. So I can write it as 2 minus 0.05. 0.05 means what you can take it as? You can take it as 1.95. You can take it as 1.95 volts, right? So this much is the terminal voltage. Hence, which option is correct? Option C is correct. So this is resistance. It has to be given in ohm. Okay, let us move on to the next question. These are from 2025 and 2024. See, range of electrical conductivity and resistivity for metals among the following. Okay, this is what they are asking. These ranges you have to remember them. These ranges are given in semiconductors chapters, so you should be knowing. You know, conductors. Conductors is the conductivity range from 10 raised to 2 to 10 raised to 8 Siemens per meter. Resistivity will be from 10 to the power minus 2 to 10 to the power minus 8 ohm meter. Right? This is for conductors. And for insulators, conductivity will be from 10 to the power minus 11 to 10 to the power minus 19 Siemens per meter. Right? And what about resistivity? Resistivity will be in positive power 10 raised to 11 to 10 raised to 19 ohm meter. Resistivity. For semiconductors, the values will be in between conductor as well as insulator. Either middle value semiconductor irtadri. So conductivity will be from 10 to the power plus 5 to 10 to the power minus 6 Siemens per meter, and resistivity will be from 10 to the power minus 5 to 10 to the power plus 6 ohm meter. This much will be the resistivity. They are asking us the range of conductivity and resistivity for what? For metals. Metals antadre conductors kelatare. So conductors are the conductivity positive power, resistivity negative power. Conductivity plus 2 to plus 8, resistivity minus 2 to minus 8. So option A itself is correct. Right? These are the ranges you have to remember. Okay, next question. An electric bulb of 60 watt 120 volt is to be connected to 220 volt source. Okay. What resistance should be connected in series with the bulb so that the bulb glows properly? Remember, we know there is a bulb connected here, right? So for this bulb, we are connecting a battery. What are the ranges of this bulb? Power of this bulb is 60 watt, and how much is the voltage? 120 volt. These are marked power and marked voltages. Marked power and marked voltage under ability, capacity. the printed value, ಅದರ ಮೇಲೆ print ಹಾಕಿರುವಂತ value. If you want to know the clear difference of this power as well as actual power and rated power and all, I have already done a clear video on that. So you can go and find the playlist called as NEET KCET current electricity. In that you will find that, right? So please go and watch that. You will get 100% clear knowledge of this power, right? Okay, ಇಲ್ಲೊಂದು ಬಲ್ಬ್ ಅದ ನಮಗೆ. ಈಗ ನೋಡ್ರಿ, ಈ ಬಲ್ಬ್ದ ರೇಂಜ್ ನಮ್ಗೆ ಎಷ್ಟದಪ್ಪ ಅಂದ್ರೆ 120 ವೋಲ್ಟ್. ಅಂದ್ರೆ ಆ ಬಲ್ಬ್ ಕೆಲಸ ಮಾಡೋದು ಬರೀ 120 ವೋಲ್ಟ್ ತನಕ ಅಷ್ಟೇ. ಅದಕ್ಕಿಂತ ಕಮ್ಮಿ ಕೊಟ್ರೆ ಕೆಲಸ ಮಾಡ್ತದ್ರಿ, ಇಲ್ಲ ಅಂತಲ್ಲ. ಬಟ್ ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಕೊಟ್ರೆ ಈ ಬಲ್ಬ್ ನಮ್ಗೆ ಏನಾಗ್ತದ್ರಿ, ಹಾಳಾಗಿ ಹೋಗ್ತದೆ. ಇಟ್ ವಿಲ್ ಗೆಟ್ ಬರ್nt ಔಟ್, right? So how much voltage we are supplying? We are supplying 220 volt to it, which is greater than the market voltage of that bulb. So ಈ ಬಲ್ಬ್ ನಮಗೆ ಇಟ್ ಶುಡ್ ನಾಟ್ ಬರ್ನ್, ಇಟ್ ಶುಡ್ ವರ್ಕ್ ಪ್ರಾಪರ್ಲಿ ಅಂತ ಹೇಳ್ತಾರ. ಸೊ ಪ್ರಾಪರ್ಲಿ ವರ್ಕ್ ಆಗಬೇಕಂತಂದ್ರೆ ಇದಕ್ಕೆ ಸಿರೀಸ್ ಒಳಗೆ ಒಂದು ರೆಸಿಸ್ಟೆನ್ಸ್ ನಾವು ಕನೆಕ್ಟ್ ಮಾಡಬೇಕು. ಸೊ ಈ ರೆಸಿಸ್ಟೆನ್ಸ್ ಎಷ್ಟದ್ದು ಇರ್ಬೇಕು ಅಂತ ಕೇಳ್ತಾರೆ. Why we have to connect that resistance in series? So that this voltage 220 gets divided, right? ಅದು 220 ಎಲ್ಲಕ್ಕೆಲ್ಲ 220 ನಮಗೆ ಬಲ್ಬ್ ಹೋಗಬಾರ್ದು, ಅದು ಡಿವೈಡ್ ಆಗಬೇಕು. ಒಂದಿಷ್ಟು ರೆಸಿಸ್ಟೆನ್ಸ್ ಹೋಗ್ಬೇಕು, ಒಂದಿಷ್ಟು ಬಲ್ಬ್ ಹೋಗ್ಬೇಕು. So that the bulb works properly, correct? That's why we have to divide it. So then divide ಮಾಡ್ಲಿಕ್ಕೆ voltage ಯಾವಾಗ ಡಿವೈಡ್ ಆಗ್ತದೆ, series combination ಒಳಗೆ voltage divide ಆಗ್ತದೆ. That's why we are connecting resistance in series. Okay, let me say we have connected a resistance R in series. ಈ 220 ವೋಲ್ಟ್ ಒಳಗಿಂದ 120 ವೋಲ್ಟ್ ಈ ಬಲ್ಬ್ ಹೋಯ್ತು. 120 ವೋಲ್ಟ್ ಆ ಬಲ್ಬ್ ಹೋಗ್ಲಿ, ಯಾಕಂದ್ರೆ ಅದರ ರೇಂಜ್ 120 ಅದು. ಉಳಿತು ಎಷ್ಟ್ರಿ, 100 ವೋಲ್ಟ್. ಸೊ that 100 ವೋಲ್ಟ್ ಹ್ಯಾಸ್ ಟು ಗೆಟ್ ಡ್ರಾಪ್ಡ್ ಅಕ್ರಾಸ್ ದಿಸ್ ರೆಸಿಸ್ಟೆನ್ಸ್. ಈ ರೆಸಿಸ್ಟೆನ್ಸ್ ಮೇಲೆ ಡ್ರಾಪ್ ಆಗಬೇಕು. ಓಕೆ, ಈಗ ನೋಡ್ರಿ, ಯು ಹ್ಯಾವ್ ವೋಲ್ಟೇಜ್, ಯು ಹ್ಯಾವ್ power. What you can calculate using marked power and marked voltage, you can calculate resistance of the bulb. Okay, only in calculating the resistance of the bulb you use marked voltage and marked power. Nowhere else you have to use it. Okay, resistance is equal to V square divided by R. Formula then V square divided by R. What is V square? 120 into 120. This is V square. What is R? Sorry, V square power is equal to V square divided by R ಇರ್ತೈತ್ರಿ. Power is equal to V square divided by R. ಇದನ್ನ ಏನ್ ಮಾಡ್ತೀನಿ, resistance is equal to V square divided by power ಅಂತ ತಗೋತೀನಿ. How much is power? Power is 60. So 60 ones are 62s are. So ಇದು ನಂಗೆ ಬಂತ 240 ohm. 240 ohm ಬಂತು. Correct? So resistance of the bulb is 240 ohm. Resistance of the bulb is 240 ohm. How much is this resistance? We have to calculate now. ಈ resistance ಎಷ್ಟದಂತ ನಾ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಓಕೆ, ಈಗ ಆ ರೆಸಿಸ್ಟೆನ್ಸ್ ನೀವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಬೇಕಂತಂದ್ರೆ, to calculate that resistance you can calculate the current of this bulb. ಈ ಬಲ್ಬ್ ಒಳಗಿಂದ ಕರೆಂಟ್ ನೀವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬಹುದು. I is equal to, it is V divided by R, right? How much is V? ಬಲ್ಬ್ದ ವೋಲ್ಟೇಜ್ ಎಷ್ಟದ? 120. How much is resistance? Resistance ನಂಗೆ 240 ಅದ, 240. So 0 0 12 ones are 12 twos are, right? So I will get 1/2. 1/2 means it is 0.5 ampere. This much is the current. So the same current has to flow in this resistor. Other current ಈ resistor ಒಳಗೆ flow ಆಗಬೇಕ್ರಿ, ಯಾಕಂದ್ರೆ series ಅದಾವ. series ಒಳಗೆ current same ಇರ್ತದ್ರಿ. It will be same. So to calculate resistance, R is equal to, we can take it as V divided by I. V already ನಮಗೆ ಗೊತ್ತದ 100 volts ಅದ. So this is 100 divided by 0.5. 0.5 means 1/2. So the resistance has to be 200 ohm, right? So which option is correct? Option C is correct. Okay, well, let us go on, move on to the next question. Okay, here they have given us an IV characteristic of a conductor at two different temperatures, 100 degrees Celsius and 400 degrees Celsius, as shown in the figure. The temperature coefficient of the resistance of the conductor would be alpha. They are asking temperature coefficient means what they are asking, alpha they are asking. This is from 2024. See whether this is IV graph or VI graph. IV graph. See, if it is VI graph, if V was here, I was here. V suppose illitta, I illittapa antandre adra slope nam resistance in ಕೊಡ್ತದ್ರಿ. V on y axis, I on x axis idre slope of that graph will give you resistance. But here it is interchanged. I is on y axis, V is on x axis. So the slope of this graph will give you reciprocal of resistance. Slope of this graph will give you reciprocal of resistance. Okay, let us take this one as first wire, this one as second one. So here this is theta 1, 30 degrees theta 1 and 45 degrees theta 2. Okay, well, and let me take for resistance of this wire as R1 and resistance of this wire as R2, and temperature here it will be 100 and here it will be 400. Temperature has to be more here. ಇಲ್ಲಿ ನಮಗೆ ಟೆಂಪರೇಚರ್ ಹೆಚ್ಚಿರಬೇಕು. Which resistance will be greater, right? ಈಗ ನಮಗೆ ಇದು ರೆಸಿಸ್ಟೆನ್ಸ್ ಹೆಚ್ಚಿರ್ತದೆ, R2 ಗಿಂತನೂ ಈ ರೆಸಿಸ್ಟೆನ್ಸ್ ಹೆಚ್ಚಿರ್ತದೆ. So where resistance is more, there their temperature has to be more. Temperature has to be more. Correct? So this is 400 degrees Celsius and this will be 300 degrees Celsius. Why? Because here the slope of this graph will give you reciprocal of resistance. Right? ಅಂದಮೇಲೆ ಇಲ್ಲಿ ರೆಸಿಸ್ಟೆನ್ಸ್ ಹೆಚ್ಚಿರಬೇಕು, ಟೆಂಪರೇಚರ್ ಹೆಚ್ಚಿರಬೇಕು. ಇಲ್ಲಿ ರೆಸಿಸ್ಟೆನ್ಸ್ ಇದರ ಸ್ಲೋಪ್ ಕಮ್ಮಿ ಅದ್ರಿ, 30 ಡಿಗ್ರಿ ಸ್ಲೋಪ್ ಕಮ್ಮಿ ಇರ್ತದೆ, 45 ಡಿಗ್ರಿ ಸ್ಲೋಪ್ ಜಾಸ್ತಿ ಇರ್ತದೆ. ಸೊ ಸ್ಲೋಪ್ ಕಮ್ಮಿ ಇದ್ದಲ್ಲೇ ರೆಸಿಸ್ಟೆನ್ಸ್ ಹೆಚ್ಚಿರಬೇಕು, ಟೆಂಪರೇಚರ್ ಹೆಚ್ಚಿರಬೇಕು. ಸ್ಲೋಪ್ ಜಾಸ್ತಿ ಇದ್ದಲ್ಲೇ ರೆಸಿಸ್ಟೆನ್ಸ್ ಕಮ್ಮಿ ಇರಬೇಕು, ಟೆಂಪರೇಚರ್ ಕಮ್ಮಿ ಇರಬೇಕು. ಲೈಕ್ ದಟ್ ವಿ ಕ್ಯಾನ್ ಟೇಕ್ ಇಟ್. ಸೊ ವಿ ಹ್ಯಾವ್ ಟು ಫೈಂಡ್ ಔಟ್ ಆಲ್ಫಾ. ನಾವು ಆಲ್ಫಾ ಫೈಂಡ್ ಮಾಡ್ಬೇಕಿಲ್ಲ. ಸೊ ಆಲ್ಫಾ ಫೈಂಡ್ ಮಾಡ್ಲಿಕ್ಕೆ ನಾನು ಏನು ಮಾಡ್ತೀನಿ, ವಾಟ್ ಐ ವಿಲ್ ಡು ಇಸ್, ಸಿ ವಿಲ್ ನೋಟ್ ಡೌನ್ ದ ಥಿಂಗ್ಸ್ ಹಿಯರ್. ವಿಲ್ ನೋಟ್ ಡೌನ್ ದ ಥಿಂಗ್ಸ್. Theta 1 is 30 degree. Theta 1 is 30 degree and resistance is R1. Temperature is T1 is equal to 400 degrees Celsius. Theta 2 is 45 degree. 45 degree. Resistance is R2. Temperature is 100 degree Celsius. This number given other. Now alpha find ಮಾಡಬೇಕಾಗಿದೆ. Since there are two resistances and two temperatures, you can use this formula. Temperature R1 divided by R2. Sorry. R2 by R1 is equal to ಅಂತ ಯೂಸ್ ಮಾಡಬಹುದು, ಇಲ್ಲ R1 by R2 is equal to ಅಂತ ಯೂಸ್ ಮಾಡಬಹುದು. Right? R2 divided by R1 is equal to 1 plus alpha T2 divided by 1 plus alpha T1 ಅಂತ ನಾ ಯೂಸ್ ಮಾಡ್ತೀನಿ. Correct? So R2 by R1. R2 and R1 we don't know. So R2 and R1 we have to calculate here. Now calculate ಮಾಡ್ಕೋಬೇಕು. So we'll calculate it like this by using the formula R is equal to R naught into the bracket 1 plus alpha T. We'll use this. Correct? So here we don't know alpha also. Correct? ನಮಗೆ alpha ಗೊತ್ತಿಲ್ಲ. ಸೊ ನಾವಿಲ್ಲಿ ರೆಸಿಸ್ಟೆನ್ಸ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೋಬೇಕು. ರೆಸಿಸ್ಟೆನ್ಸ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲಿಕ್ಕೆ ನಮಗೆ ಸ್ಲೋಪ್ ಯೂಸ್ ಮಾಡಬಹುದು. ಓಕೆ, ವಿ ಕ್ಯಾನ್ ಯೂಸ್ ಸ್ಲೋಪ್. See, R1 is equal to, I can take 1 divided by slope of first line, and R2 is equal to, I can write 1 divided by slope of second line. Slope of second line. So the 1 divided by slope of first line is tan 30 degree. So tan 30 degree. Correct? Tan 30 degree ಅಂದ್ರೆ ನೀವೇನಂತ ತಗೋಬಹುದು, 1 by root 3. ಇದು 1 by root 3 ಆದ್ರೆ ಇದು ನಂಗೆ ಬಂತ root 3. Correct? R1. R2, 1 by slope of second line. Second line is 45 degree. So I will take it as tan 45 degree. Tan 45 degree means it will be 1. Correct? So we got R1 value as well as R2 value. R2 is 1 ohm. R1 is root 3 equal to 1 plus alpha T2. T2 is 100. So this I will call it as 100 alpha. 1 plus this I will call it as 400 alpha. Correct? Cross multiply, you will get 1 plus 400 alpha is equal to root 3 plus root 3 into 100 alpha. Cross multiplying. Okay, I will take this root 3 on this side. I will get it as 1 minus root 3. 1 minus root 3. So here on this side, you will get this one as, see, or you can take it like this. You can take it like this. This is 400 alpha. Take that root 3 100 alpha on this side. This will be root 3 100 alpha. And on this side, I can write it as root 3 minus 1. So this is 400 alpha minus root 3 is 1.73. We know that root 3 is 1.73. So 1.73 into 100 will be 173 alpha, right? Equal to 1.73 minus 1 will be 0.73. 0.73. Okay, 400 minus 1.73. How much I will get? 220, 227 I will get, right? So 227 alpha is equal to 0.73. Now I want alpha. So alpha is equal to 0.73 divided by 227. Now I can write it like this. See, 227, 0.73 another idana 730 into 10 to the power minus 3 anta baritene, divided by 227 another then 230 anta barkotine. I will write it as 230. Okay? Just for simplification, I am taking it like this. 0 and 0 will get cancelled. So if I say this is 25 and this is 75, 25 ones are 25 3s are 75 will get. Correct? So what I got, alpha is equal to, I get it as 3 into 10 to the power minus 3. Hence, which option is correct? Option A is correct. Right? Let us move on to the next question. See, the electric current flowing through a given conductor varies with the time as shown in the graph below. The number of free electrons which flows through a given cross section of conductor in time interval 0 to 20 seconds. Only up till 20 seconds they are asking. This is 20 seconds. Right? Up till 20 seconds they are asking you. What we have to do? We have to calculate number of charges. So number of charges calculate ಮಾಡಬೇಕಂದ್ರೆ ಇದು ನೋಡ್ರಿ. This is I versus T graph, current versus time. So the area of this graph will give you charge. Area of this graph will give you charge. Right? So first area calculate ಮಾಡೋಣ, ಆಮೇಲೆ number of charges calculate ಮಾಡೋಣ. So area calculate ಮಾಡಬೇಕಾದ್ರೆ ನೋಡ್ರಿ, ಇಲ್ಲೇ ನಿಮ್ಗೆ ಒಂದು ಟ್ರೆಪೆಜಿಯಮ್ ಸಿಗ್ತದ್ರಿ, ಒಂದು ರೆಕ್ಟಾಂಗಲ್ ಸಿಗ್ತದ, ಅಥವಾ ಟ್ರಯಾಂಗಲ್, ರೆಕ್ಟಾಂಗಲ್ ಅಂಡ್ ರೆಕ್ಟಾಂಗಲ್ ಕೂಡ ಸಿಗ್ತದ್ರಿ. See, this is first right angle triangle we will get. First right angle triangle we will get. Here we have a rectangle. Illondu namge rectangle sigtadri, correct? And here we have another rectangle. This is another rectangle, correct? This is another rectangle. So here let us calculate the charge first. So charge Q is equal to area of triangle 1, area of triangle 1, area of triangle plus area of rectangle 1, area of rectangle number 1 plus area of rectangle number 2. ನೀವು ಟ್ರಾಪೆಜಿಯಮ್ದು ಫಾರ್ಮುಲಾ ಅಪ್ಲೈ ಮಾಡಬಹುದು, ರೈಟ್? ಈ ಟ್ರಯಾಂಗಲ್ ಮತ್ತು ರೆಕ್ಟಾಂಗಲ್ ಕೂಡ ಇದೊಂದು ಟ್ರಾಪೆಜಿಯಮ್ ಅದ. ಟ್ರಾಪೆಜಿಯಮ್ದು ಫಾರ್ಮುಲಾ ನೀವು ಅಪ್ಲೈ ಮಾಡಬಹುದು. You can apply the trapezium formula also. Okay, area of triangle half into base into height. See, this is called base of the triangle. Base of the triangle ನಂಗೆ ಎಷ್ಟದೆ? It is 10. This is base of the triangle. See, this is base of the triangle. This much is the base of the triangle. How much it is? It is 10. Right? So base is 10. How much is the height? This is called height. Right? ಈಗ ಇಲ್ಲೇ ನೋಡ್ರಿ, ಇಲ್ಲೇ ನಮಗಿದು 200 ಇದೆ, ಇದು 400 ಇದೆ. Then what is this? This is 300. What is this? This is 100. We want this value. E value ನಮಗೆ ಬೇಕಾಗಿತ್ತು. This value we want. So how much is this? 300 minus 100 means it will be 200. ಅದು ನಮಗೆ 200 ಇರ್ತದ್ರಿ. So this is 200 plus area of rectangle, length into breadth. ಈ rectangle ತಗೊಳ್ರಿ. 10 into 100. This is 100. This is 10. So this will be 10 into 100, length into breadth. Plus area of rectangle number 2. ಈ rectangle ತಗೊಳ್ರಿ. So ಈ rectangle height ನಮಗೆ 300 ಇದೆ. And this is 10. 20 minus 10, this will be 10. This is 10, this is 300. So it is 300 into 10. Okay, let us simplify. 2 into 2 ones are 200. 100 into 10 is 10 raised to 3. 100 into 10 is 10 raised to 3. 300 into 10. So this I can write 3 into 10 raised to 3. So what I will get? I will get 3, 4, 5. If I take 10 raised to 3 common, it will be 5 into 10 raised to 3. So this much charge I got. What they are asking? They are not asking charge. They are asking number of charges, number of electrons. So number of electrons under by principle of quantization, I can write it as n into E is equal to 5 into 10 raised to 3. Right? So n is equal to 5 into 10 raised to 3 divided by E. How much is E? 1.6 into 10 to the power minus 19. Correct? So here let me take this one as 1.5. If I take it as 1.5, 1.5 3 side will be 4.5. So 4 is right. So near about 4, less than 4 it will be. Minus 19 ಮೇಲ್ಗಡೆ ಬಂದ್ರೆ ಇದು plus 19 ಆಗಿ ನಮಗೆ 10 to the power 22 ಬರ್ತದೆ. 10 to the power 22. Correct? And this is something 5 divided by 1.6. So 3 point something we have to get. It is not 4. It has to be less than 4. 4 ಕಿಂತ ಕಮ್ಮಿ ಇರಬೇಕು. ಆಮೇಲೆ ಪವರ್ ನೋಡ್ರಿ, ಇದು minus 19 ಅದೇ, ಇದು plus 3 ಅದ. minus 19 ಮೇಲ್ಗಡೆ ಹೋದ್ರೆ plus 19 plus 3 will be 10 to the power plus 22. So this has to be 3 point something into 10 to the power plus 22. Let me say 3 point, okay, 3 point less than 4 ಅಂದ್ರೆ 3.5 ಅಂತ ತಗೋತೀನಿ, ಅಥವಾ 3.5. Okay, let us take it as 3.5. 10 to the power 22 ಅದ. ಇಲ್ಲಿ ಆನ್ಸರ್ಸ್ ಎಲ್ಲ ನಮಗೆ 10 to the power 19 ಒಳಗದೆ, 10 to the power 18 ಒಳಗದೆ. ಸೊ 10 to the power 19 ಒಳಗೆ ನೀವು ಇದನ್ನ ಹೇಳಬೇಕಂತಂದ್ರೆ, ಇದು 10 to the power 19 ಒಳಗೆ ನೀವು ಬರೀಬೇಕಂತಂದ್ರೆ, ಈಗ ನಾ ಇದನ್ನ ಇಲ್ಲಿ ಏನ್ ಮಾಡ್ಬೇಕಾಗ್ತದಪ್ಪ ಅಂತಂದ್ರೆ, ಲೆಟ್ ಅಸ್ ಚೆಕ್. ಸಿ, ದಿಸ್ ಇಸ್ 22 ಇದು 19 ಆಗ್ಬೇಕಂತಂದ್ರೆ ಈ 10 to the power ಇದಕ್ಕೆ ಮಲ್ಟಿಪ್ಲೈ ಆಗ್ಬೇಕು. ಸೊ 5 divided by 16, 1.6, or I can write it like this: 5 into 10 to the power 3 divided by, I will write it as 16 into 10 to the power minus 20. Correct? So here we can write 5 ones are 5 3s ಅಂತ ತಗೊಂಡ್ರೆ, then 15 ಅಂತ ತಗೊಂಡ್ರೆ 1 divided by 3 into 10 to the power 23. 1 divided by 3 will be 0.333 into 10 to the power 23, or you can write it as 3.33 into 10 to the power 22 ಅಂತ ನಾವು ಬರೀಬಹುದು. ಬಟ್ 10 to the power 22 ದ ಪವರ್ ನಮಗೆ ಇಲ್ಲೇ ಕೊಟ್ಟಿಲ್ಲ. ಸಾರಿ, ಇಲ್ಲೇ ನಮ್ಮ ಕರೆಂಟ್ ಮಿಲಿ ಅಂಪಿಯರ್ಸ್ ಒಳಗದ್ರಿ. ವಿ ಹ್ಯಾವ್ ಫಾರ್ಗಟನ್ ದಿಸ್. ಕರೆಂಟ್ ಇಸ್ ಇನ್ ಮಿಲಿ ಅಂಪಿಯರ್ಸ್, ಸೊ ವಿ ಹ್ಯಾವ್ ಟು ಟೇಕ್ ದಿಸ್. ಮಿಲಿ ಅಂಪಿಯರ್ಸ್ ಒಳಗೆ ಕರೆಂಟ್ ನ ಏನಾದರೂ ತಗೊಂಡ್ರೆ, ಇಫ್ ಐ ಟೇಕ್ ಇಟ್ ಇನ್ ಮಿಲಿ ಅಂಪಿಯರ್ಸ್, ಇಲ್ಲಿ ನಮಗೆ 10 to the power -3 ಒಂದು ಬರಬೇಕು. ಫಾರ್ ದಿಸ್ ವಿ ವಿಲ್ ಗೆಟ್ 10 to the power -3. ಇದಕ್ಕೂ ಕೂಡ 10 to the power -3 ಬಂದ್ರೆ ಇದು ಕೂಡ ಆನ್ಸರ್ ಕರೆಕ್ಟ್ ಬರ್ತದ್ರಿ. ಸೊ -3 ನೀವು ಇಲ್ಲಿ ತೆಗೆದ್ರೆ ಇದು ನಿಮಗೆ ಬಂತ 3.33 into 10 to the power 19 ನಿಮಗೆ ಬರ್ತದ್ರಿ. into 10 to the power 19. Correct? So which option is correct? Option A is correct. Okay, let us move on to the next question. Okay, here we have a network here. See, types of resistor circuits and how to solve the different methods of solving the resistor circuits I have already taught in those videos in very detail. Right from identifying the series as well as parallel combination, from that I have started. So you'll get a clear cut idea about how to identify the combinations and how to solve the advanced circuits. So please go and watch that channel, video of NEET and KCET current electricity. Right? From very depth we will get the knowledge. Okay, here they are asking us in the circuit shown, the end A is at potential V0, okay, and end B is grounded. Grounded antandre itarada potential 0 antandre, VB is equal to 0 antandre. Okay, the electric current I indicated in the circuit. So they are asking you this current. See, first of all, ee circuit nodidmele nimage idu gottagbeku. See, this is a Wheatstone's network. Actually, ee tara namage circuit idre idu Wheatstone's network. This is a Wheatstone's network, right? So this is called P, this is called R, this is called S, right? ಈ ತರ ಇರ್ತದೆ ನಮಗೆ. ಈಗ Wheatstone's network ಇತ್ತಪ್ಪ ಅಂತಂದ್ರೆ ನಾವು ಏನ್ ಮಾಡ್ಬೇಕು, ಫಸ್ಟ್ ಅದು ಬ್ಯಾಲೆನ್ಸ್ ಇರೋದನ್ನ ಎಲ್ಲ ಚೆಕ್ ಮಾಡಬೇಕು. ಬ್ಯಾಲೆನ್ಸ್ ಇದ್ರೆ ನೀವು ಏನ್ ಮಾಡ್ಬೇಕು, ಮಿಡಲ್ ರೆಸಿಸ್ಟರ್ ನೀವು ತೆಗೆದು ಹಾಕಬೇಕು. So this is balanced, R by R, R by R, it is balanced. So you can leave this resistor, ಈ resistor ನೀವು ತೆಗೆದು ಹಾಕಬಹುದು. So if you remove this resistor, what happens now? These both will be in series. P and R will be in series, Q and S will be in series, and these both will be in parallel. So here R and R will become in series. R and R series andre 2R aite. This R and this R will become in series. Itarde 2R aite. So 2R and 2R will become parallel. So this is 2R, this is 2R. 2R and 2R will become parallel. Hence the effective of this will become equal to R. Right? So this side we got the effective R. ಈ ಕಡೆ ನಮಗೆ effective R ಬಂತು. ಈ ಕಡೆ effective ನೋಡ್ರಿ, ಈ ಕಡೆ ನಮಗೆ 2R ಅಂತ ಹೇಳಿದೆ. So ಈ middle resistor ಬಿಟ್ಟು ಬಿಡ್ರಿ, these both will become series, this will become 4R, these both will become series, this will become 4R, 4R and 4R in parallel, so the effective will be 2R, So what is the total resistance in the circuit now? Total resistance will be equal to R plus 2R. Why? Because this circuit and this circuit both are in series. ಇವೆರಡು series ಒಳಗೆ ಇರೋದ್ರಿಂದ total resistance ನಂಗೆ 3R ಅಂತ ಬರ್ತದೆ. They are asking us current. So current is equal to potential difference. Potential difference V0 minus 0, it will be V0 divided by resistance 3R. So V0 divided by 3R, which is the correct option then? Correct option is option D. Okay, let us move on to the next question. Vector E is the electric field inside a conductor whose material has conductivity sigma and resistivity rho. The current density inside the conductor is J. The correct form of Ohm's law. Ohm's law, the vector form ನಿಮಗೆ ಕೇಳತಾರೆ. Vector form of Ohm's law ನಮಗೆ ಗೊತ್ತದ್ರಿ. It is vector form of Ohm's law is like this. We know this. Current density is equal to sigma into electric field, conductivity into electric field, or you can write it as electric field is equal to 1 divided by sigma into current density. 1 divided by sigma is resistivity, right? Resistivity. So electric field is equal to resistivity into current density, or current density is equal to conductivity into electric field. So which is correct then? Correct option is option C. Okay, let us move on to the next question. Okay, this question is from 2023. See, about infinite networks. This is an infinite network of electrical resistances. There are variety of infinite networks. About infinite electrical networks of resistors, I have made a separate video on that infinite networks. And I have classified the infinite networks in three types. And I have also given you the shortcuts in those methods, right? So please go and watch that video of infinite networks. You will find a clear cut idea, and also you will get the answer of this circuit within a step, right? So if you want to know that method as well as the shortcut formulas for that and tricks for that, please go and watch that video. So here, since here we are having three resistors and the same combination of three resistors have been connected, copy pasted up till the infinity. So we have to find out the equivalent resistance. In such circuits, this circuit nodid koodle naಮಗೆ ಗೊತ್ತಾಗ್ತದೆ effective resistance in between EB. If you watch that videos, you will get to know it will be root 3 plus 1, root 3 minus 1 into R. ಅಂತೇಳಿ ನಿಮಗೆ ಗೊತ್ತಾಗ್ತದೆ. Root 3 It will be actually root 3 plus 1 into r, right? So how much you will get? See, root 3 is 1.73 plus 1 into r is 2. So 1.73 means it is 2.73 into 2. So 2.73 means 2 3s are 6, 2 7s are 14, 2 2s are 4 plus 1 5, 5.46 ohm. ಎಷ್ಟು ನಮಗೆ effective ಬರಬೇಕು. So 5.46 means its nearest value is option B. So this is correct. ಓಕೆ, ನಾ ಡೈರೆಕ್ಟ್ಲಿ ಇದು ಹೆಂಗೆ ತಗೊಂಡು ಅನ್ನೋದು ಈಗ ನಿಮಗೆ ಕ್ವಶನ್ ಇರ್ತೈತ್ರಿ. ರೂಟ್ 3 ಪ್ಲಸ್ 1 ಇಂಟು ಆರ್. ಈ ಸರ್ಕಿಟ್ ನ ನೋಡಿದ ಕೂಡಲೇ ವಿಚ್ ಟೈಪ್ ಆಫ್ ಇನ್ಫೈನೈಟ್ ನೆಟ್ವರ್ಕ್? ಇನ್ಫೈನೈಟ್ ನೆಟ್ವರ್ಕ್ ಒಳಗೆ 3 ಟೈಪ್ಸ್ ಆಗಿ ನಾ ಡಿವೈಡ್ ಮಾಡಿದ್ದೀನಿ. ಅದ್ರೊಳಗೆ ಇದು ಥರ್ಡ್ ಟೈಪ್ ಆಫ್ ಇನ್ಫೈನೈಟ್ ನೆಟ್ವರ್ಕ್ ಅದ್ರಿ. ಸೊ ಈ ತರ ಐಡೆಂಟಿಕಲ್ ರೆಸಿಸ್ಟರ್ಸ್ ಇರುವಂತ ಥರ್ಡ್ ಟೈಪ್ ನೆಟ್ವರ್ಕ್ ಬಂದ್ರೆ ಡೈರೆಕ್ಟ್ಲಿ ಯು ಹ್ಯಾವ್ ಟು ಯೂಸ್ ದಿಸ್ ಫಾರ್ಮುಲಾ, ಯು ವಿಲ್ ಗೆಟ್ ದ ಆನ್ಸರ್ ವಿದಿನ್ ಸೆಕೆಂಡ್ಸ್. ಸೊ ಈ ತರ ಇನ್ಫೈನೈಟ್ ನೆಟ್ವರ್ಕ್ಸ್ ವೆರೈಟೀಸ್ ಏನದಾವ ಅದನ್ನೆಲ್ಲಾನು ಕೂಡ ಆ ವಿಡಿಯೋದಲ್ಲಿ ನಾನು ಹೇಳಿದ್ದೀನಿ ಕ್ಲಿಯರ್ ಆಗಿ. So you will get to know how to solve the infinite networks within seconds, and you will get the shortcuts very clearly. Please go and watch that video. Right? NEET and KCET current electricity playlist hogri athroge last video the infinite networks. Okay, we'll move on to the next question. These both are from 2023. Okay, 10 identical cells, each of EMF 2 volt and internal resistance 1 ohm are connected in series with 2 cells wrongly connected. Okay, wrongly connected cells is the concept. A resistor of 10 ohm is connected to the combination. What is the current through the resistors? Okay, external resistance ನಮಗೆ 10 ohm ಇದ್ದದೆ, right? ಆಮೇಲೆ internal resistance 1 ohm, EMF is 2 volts. See, wrongly connected identical cells ಇದ್ದಪ್ಪ ಅಂತಂದ್ರೆ ನಮಗೆ effective EMF ಅಥವಾ equivalent EMF ನಾವು ಬರಿತೀವಿ n minus 2m into E. n minus 2m into E. n is total number of cells, that is 10. m is number of cells which are wrongly connected. 2 cells are wrongly connected. E is the EMF of the identical cells. So this will be 2 into 2 4, and 10 minus 4 will be 6. 6 into 2 will be 12. So effective EMF is 12 volts. Effective EMF is 12 volts. Correct? So total 10 identical cells. So 10 I have taken. 2 cells are wrongly connected. So it is 4. 10 minus 4 is 6. 6 into 2 will be 12. So equivalent EMF ನಮಗೆ ಎಷ್ಟು ಬಂತು? ನಮಗೆ ಏನು ಕೇಳತಾರೆ? They are asking us what is the current through the external resistance. Okay, current ನಿಮಗೆ ಬೇಕಿತ್ತಂತಂದ್ರೆ current ನೋಡ್ರಿ equivalent EMF ಆಯ್ತು. Equivalent internal resistance ಎಷ್ಟು ಆಗ್ತದ್ರಿ? Each cell is having 1 ohm. So there are 10 cells connected in series. So ಇಲ್ಲೇ ನಮಗೆ effective 10 ohm ಆಗ್ತದ್ರಿ. ಆರ್ equivalent, right? ಇಲ್ಲೇ ನಮಗೆ ರೆಸಿಸ್ಟೆನ್ಸ್ ಆಗ ಏನು ಮೈನಸ್ ಆಗಂಗಿಲ್ಲ. ಯಾಕಂದ್ರೆ ರೆಸಿಸ್ಟೆನ್ಸ್ ನೀವು ಸೆಲ್ಸ್ ಹೆಂಗ ಕನೆಕ್ಟ್ ಮಾಡ್ರಿ, ಕರೆಕ್ಟ್ ಕನೆಕ್ಟ್ ಮಾಡ್ರಿ, ರಾಂಗ್ಲಿ ಕನೆಕ್ಟ್ ಮಾಡ್ರಿ, ಅವು ನಮಗೆ ಏನಾಗ್ತಾವಪ್ಪ ಅಂತಂದ್ರೆ ಅವು ಆಡ್ ಹಾಕೋತ ಹೋಗ್ತಾವ್ರಿ. ಓಕೆ, I is equal to E divided by R plus R. I is equal to E divided by R plus R. How much is E? E ಅಂದ್ರೆ E equivalent ತಗೊಳ್ರಿ, it is 12. How much is external resistance? External resistance is of 10 ohm. And how much is internal? It is also of 10 ohm. So 12 divided by 20 will get 12 divided by 20. So 2 10s are 2 6s are. So we will get it as 0.6 ampere. 0.6 ampere. So current is 0.6 ampere. Option C. We'll go on to the next question. For given electric current, the drift velocity of conduction electrons in a copper wire is Vd and their mobility is mu. When the current is increased at constant temperature. Okay, what happens to drift velocity? What happens to mobility? They are asking. See, drift velocity and current relation, we know this. I is equal to N E A Vd anta namagu gottade. So current is directly proportional to drift velocity. So if you increase current, drift velocity has to increase. So ille namagu drift velocity increase ಆಗ್ತಿರುವಂತ ಆಪ್ಷನ್ ಒಂದೇ ಕೊಟ್ಟಿದಂತೆ, right? So option A is correct. Ille remains same andana, ille decreases andana, remains same andana. So these will get eliminated. And if you want to see that in case of mobility, see, mobility is equal to, we know, mobility is equal to, we know it is drift velocity per unit electric field. So here you have to derive the relation between mobility and current. ಯಾಕಂದ್ರೆ current increase ಮಾಡತ್ತಾರೆ. So ಇಲ್ಲಿ ಏನ್ ಮಾಡ್ರಿ, mobility ಅಂತಂದ್ರೆ I will substitute, sorry, drift velocity means I will substitute it as I divided by NEA, drift velocity. Electric field means I will substitute it as V by L. V by L. Right? V by. Sorry. Okay. I into L. So E is equal to V by L. L melgade hoytu. So by Ohm's law, you can substitute. V means you can take it as I into R. So I and I will get cancelled. So mobility is independent of current. Mobility is independent of current. That's why mobility remains same. As it is. Okay, we'll move on to the next question. So this is from 2023, that is from 2022. Okay, a wire of resistance R is connected across a cell of EMF E and internal resistance R. The current through the circuit is I. In time t, the work done by the battery to establish the current I. Okay, work done by battery namak kelatare. See, work done is equal to, we know this very well. Work done is equal to, it is V into Q. V into Q. Right? How? Potential difference is equal to work done per unit charge. So V ಅಂತಂದ್ರೆ ನಾನು ಅದನ್ನ E ಅಂತ ತಗೋತೀನಿ. Q ಅಂತಂದ್ರೆ ಅದನ್ನ I into ತಗೋತೀನಿ. How? Because I is equal to Q by T, rate of flow of charge. So W is equal to E into I into T. Correct? So E into I into T, which is the correct option here. Option is correct. Let us move on to the next question. A wire of certain material is stretched slowly by 10%. Its new resistance and specific resistance becomes respectively. Okay, wire stretch ಮಾಡಿದರೆ 10%. How much will be the new resistance ಅಂತ ಕೇಳ್ತಾರೆ. Stretching and compression ಮೇಲೆ ಅದ್ರ ಮೇಲೆ ಕೂಡ ಒಂದು separate video ಇದೆ. I've told all the shortcuts related to those things, so you will get a clear idea about that. I will directly use the formula. So in stretching case, R dash equal to N square times of R. We know this. So how much is N here? N will be 1.1. 1.1 square times of R. So 1.1 square means 1.21 and original resistance is R. So it will increase 1.21 times. So how we got N is equal to 1.1? See, ಇಲ್ಲಿ ನಮಗೆ ಏನು ಮಾಡಿದ್ದಾರೆ, length has been increased 10% ಅಂತಂದ್ರೆ. So new length will be equal to original length plus 10% of original length. If I take length common, 1 plus 10% I will get. So here I can write it as 1 plus 0.1. 0.1 plus 1 means it will be 1.1 times of L. So we got N is equal to 1.1. Substituting that, we will get this. Which option is correct? Option is correct. Let us move on to the next question then. Okay. If a voltage across a bulb rated 220 volt 100 watt drops by 2.5% of its rated value, the percentage of the rated value by which the power would decrease. They are dropping voltage and they are asking us how much will be the drop in the power. So you should know the relation between power and voltage. See, power is equal to, we have the formula. Power is equal to, we have the formula like this. Power is equal to, we have formula V into I, V square by R, right? V square divided by R, I square into R, like this we have the formula, right? So ille namaga voltage drop agittu anta helತಾರೆ. So power is directly proportional to voltage square, right? You cannot take this because current will also be varying anta ತಗೋಬೇಡ್ರಿ, resistance constant ಇರ್ತದೆ, so ಇದು ತಗೋರಿ. ಪವರ್ ನಮಗೆ ಎಷ್ಟು ವೇರಿ ಆಗೈತೆ ಅಂತ ಕೇಳ್ತಾರೆ. ವೋಲ್ಟೇಜ್ ಎಷ್ಟು ವೇರಿ ಆಗೈತ್ರಿ? 2.5%. ದೆನ್ ಪವರ್ 2.5% 2 times ನಮಗೆ ವೇರಿ ಆಗ್ತದೆ ಅಂದಂಗ್ರಿ, ರೈಟ್? ಬಿಕಾಸ್ ಪವರ್ is 2, so it will be 5%, right? It will be 5%. So option A is correct. Okay, let us move on to the next question. Okay, these are also from 2022. See, a charged particle is moving in an electric field of 3 into 10 to the power minus 10 volt per meter with mobility 2.5 into 10 raised to 6 meter square per volt second. Its drift velocity. Okay, they are asking us drift velocity. Mobility is given. First thing, mobility is given, electric field is given. So mobility is equal to drift velocity per unit electric field. We know this. What we want? We want drift velocity. So drift velocity is equal to mobility into electric field. So mobility yesterday, mobility is 2.5 into 10 to the power 6. Amele, this is 3 into 10 to the power minus 10. So 3 into 2.5. 3 into 2.5 will be 7.5. So there is a direct answer, 7.5. This is correct. Okay, we'll move on to the next question. In an atom, electron revolves around the nucleus along a path of radius 0.72 angstrom, making 9.4 into 10 to the power 18 revolutions per second. Revolutions per second ಅಂತ ಏನು ಕೊಟ್ಟಿರ್ತಾರೆ, that is frequency. Revolution per second ಅಂತ ಏನು ಕೊಟ್ಟಿರ್ತಾರಲ್ಲ, that is frequency. So ಇಲ್ಲಿ frequency given ಅದ. Frequency is 9.4 into 10 to the power 18, correct? And radius is given, radius is 0.72 angstrom. They are asking us current due to revolving charge. See, recent KCET 2026 ಅಂತ series ಏನಿದೆ, ಅದು ಆಲ್ರೆಡಿ ಅಪ್ಲೋಡ್ ಮಾಡಿದ್ದೀನಿ ನಾನು. ಅಲ್ಲಿ ಕರೆಂಟ್ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಚಾಪ್ಟರ್ ಒಳಗೆ ಸ್ಟಾರ್ಟಿಂಗ್ ಕರೆಂಟ್ ಇಕ್ವೇಷನ್ ಬರೀಬೇಕಾದ್ರೆ ಇದು ರಿವಾಲ್ವಿಂಗ್ ಚಾರ್ಜ್ ಕರೆಂಟ್ ಇಕ್ವೇಷನ್ ಹೇಳಿದೆ ನಿಮಗೆ. ಸೊ ಅಲ್ಲಿ ಕರೆಂಟ್ ನಮಗೆ ಸಿ ಇಟ್ ಇಸ್ Q by T. Q by T ಅಂದ್ರೆ ಇದನ್ನು Q into F ಅಂತ ತಗೋಬಹುದು, Q into F. ಸೊ ಇಲ್ಲೇ ನೀವು ಡೈರೆಕ್ಟ್ಲಿ ಏನು ಮಾಡ್ರಿ, Q ಅಂತಾರೆ ಚಾರ್ಜ್ ಆಫ್ ಅನ್ ಎಲೆಕ್ಟ್ರಾನ್ 1.6 into 10 to the power minus 19 and it is 9.4 into 10 to the power plus 18, right? So here you can take this directly, ಇದನ್ನ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ಕೊಂಡ್ರೆ ನಿಮ್ಗೆ ಆನ್ಸರ್ ಬರ್ತದೆ, right? So Q into F ಯೂಸ್ ಮಾಡ್ಕೊಂಡು. Okay, we'll move on to the next question. 2022. Two identical cells, each of potential difference E. Sorry, 10 identical cells, each of potential difference E and internal resistance R are connected in series to form a closed circuit. An ideal voltmeter is connected across 3 cells. Okay, that will read. ಏನು ಮಾಡಿದಾರ್ರಿ? 10 identical cells are there, like this. They are connected in series. Okay, ಈ ತರ ನಮಗೆ series ಒಳಗೆ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ದಾರೆ. To form closed loop under 1, 2, 3, 4, 5, 6, 7, 8, 7 ಆಯ್ತಾ? ಓಕೆ, 10 ಅದಾವೆ, ಟೋಟಲಿ 10 ಅದಾವೆ. ಸೊ ಕ್ಲೋಸ್ಡ್ ಲೂಪ್ ಬರ್ಬೇಕಂತ ಹೇಳಿದ್ದಾರೆ. ಸೊ ಇಲ್ಲಿ ನಾವು 3 ಸೆಲ್ಸ್ಗಳನ್ನು ಕನೆಕ್ಟ್ ಮಾಡ್ಕೊತೀವಿ. ಐ ವಿಲ್ ಕನೆಕ್ಟ್ 3 cells here. ಕ್ಲೋಸ್ ಲೂಪ್ ಒಳಗೆ ಕನೆಕ್ಟ್ ಇರಬೇಕಂತ ಹೇಳಿದ್ದಾರೆ. ಸೊ ಐ ವಿಲ್ ಕನೆಕ್ಟ್ ಇಟ್ ಲೈಕ್ ದಿಸ್. ರೈಟ್, ಇವೆಲ್ಲ ಸೀರೀಸ್ ಅದಾವ್ರೆ ಈಗ, ಆಲ್ ಆರ್ ಇನ್ ಸೀರೀಸ್ ಅಂಡ್ ನೋ ಸೆಲ್ ಇಸ್ ರಾಂಗ್ಲಿ ಕನೆಕ್ಟೆಡ್. ಇಲ್ಲಿ ಇದಕ್ಕೊಂದು ವೋಲ್ಟ್ ಮೀಟರ್ ಕನೆಕ್ಟ್ ಮಾಡ್ತಾರೆ. ಹೌ ಮಚ್ ಇಸ್ ದ ವೋಲ್ಟೇಜ್ ರೀಡಿಂಗ್ ಆಫ್ ದಿಸ್? ಫಸ್ಟ್ ಈಕ್ವಲೆಂಟ್ EMF ಎಷ್ಟು ಆಗ್ತದೆ? If all are in series, how much will be the equivalent EMF? It will be 10. How much will be the equivalent internal resistance? It will be 10R. Right? So here, if you want to calculate how much is the current, ideal voltmeter reading ಕೇಳ್ತಾರೆ ನಿಮಗೆ. ವೋಲ್ಟ್ಮೀಟರ್ ರೀಡಿಂಗ್ ಅಂತಂದ್ರೆ ಇತರದ ವೋಲ್ಟೇಜ್ ಎಷ್ಟು, ಇತರದ ವೋಲ್ಟೇಜ್ ಎಷ್ಟು, ಇತರದ ವೋಲ್ಟೇಜ್ ಎಷ್ಟು, ಟರ್ಮಿನಲ್ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಅದನ್ನ ನೀವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೋಬೇಕು. ಫಸ್ಟ್ ಐ ನೋಡ್ರಿ, ಕರೆಂಟ್ equivalent divided by R equivalent ಅಂತ ನಾ ತಗೋತೀನಿ ಕರೆಂಟ್. ಸೊ 10E divided by 10R, this will give you E divided by R. This much is the current. ಇಷ್ಟು ಕರೆಂಟ್ ಅದ ನಮ್ಗೆ. ಇನ್ ವೋಲ್ಟೇಜ್ ಆಫ್ ಒನ್ ಬ್ಯಾಟರಿ ದ ಟರ್ಮಿನಲ್ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ರಿ. E minus IR. So this will be E minus ಇದು ಎಷ್ಟದ? E divided by R into R. ಸೊ R ಕ್ಯಾನ್ಸಲ್ ಆಯ್ತು, E minus E ನಮಗೆ 0 ಬಂತು. ಓಕೆ, 0 ಬರೋದಿಲ್ಲ. Okay, let us see external resistance ಐತೆ. Is there any external resistance? An ideal voltmeter ಅಂತ ಹೇಳಿದಾರೆ. Ideal voltmeter ಅಂದ್ರೆ ಅದರ resistance 0 ಇರ್ತದೆ. So we have to calculate how much is the ಇಲ್ಲಿ terminal potential difference ತಗೋಬೇಡ್ರಿ. Don't take terminal potential difference. Take potential difference. Okay, potential difference means I into R. So I is E divided by R into R. R will get cancelled. You will get E. So ಇತರದ potential difference E ಬಂದ್ರೆ ಇತರದು potential difference E, ಇತರದು potential difference E. So they are in series, hence the voltage has to be 3E. Right? It has to be 3E. Option D. Okay, let us move on to the next question. This is from 2021. Consider an electrical conductor connected across a potential difference V. Let delta Q be the small charge moving through it in time delta T. If I is the electric current through it, kinetic energy of the charge increases by IV delta T. Electric potential energy of the charge decreases by IV into delta T. The thermal energy of the conductor increases by IV delta T. See, ಇದಕ್ಕೆ ನಿಮಗೆ ಮೆಕ್ಯಾನಿಸಮ್ ಆಫ್ ಕರೆಂಟ್ ಫ್ಲೋ ಗೊತ್ತಿರಬೇಕು. ಸಿ ಈಗ ಒಂದು ಕಂಡಕ್ಟರ್ ಒಳಗೆ ನಮಗೆ ಚಾರ್ಜಸ್ ಮೂವ್ ಆಗಬೇಕು. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಮೂವ್ ಆಗಬೇಕಾದ್ರೆ ದೇ ವಿಲ್ ಮೂವ್ randomly. Why? Because of collisions. So in every collision, whatever kinetic energy it has gained, that will be lost. Kinetic energy will be lost. So ಅಲ್ಲಿ increase ಆಗೋ ಚಾನ್ಸಸ್ ಇಲ್ಲ. Kinetic energy increase ಆಗೋ ಚಾನ್ಸಸ್ ಇಲ್ಲ. So first option is wrong. Second one, electric potential energy of the charge decreases. Obviously, because electrons will be moving from the higher potential region. Higher potential antandre ಆ charges from the region where the electrons is more to the region where the electrons is less. So charges will be moving from higher potential region to lower potential region. Potential energy ಅಂತಂದ್ರೆ it is Q into V. Potential energy ಅಂದ್ರೆ Q into V. So V ನಮಗೆ decrease ಆಗ್ತಿರ್ತದೆ. Because charges will be moving from higher potential to lower potential region. Higher potential to lower potential region. So potential decreases. Hence potential energy also decreases. So ಇಲ್ಲಿ potential energy decrease ಆಗ್ತದೆ ಅಂತ ಕೊಟ್ಟಿದ್ದಾನೆ. That is correct. Second statement is correct. Third statement, see, ಇಲ್ಲಿ ಏನಾಗ್ತದೆ? The kinetic energy gained by that electron. ಈಗ ನೋಡ್ರಿ, ಈ collision ದಿಂದ ಈ collision ಬರೋದ್ರೊಳಗಾಗಿ its velocity increases and its kinetic energy increases, and that kinetic energy after this collision becomes zero. ಆ kinetic energy ನಮ್ಗೆ ಹೋಗಿಬಿಡ್ತದೆ, ಯಾಕಂದ್ರೆ ಅಲ್ಲಿ collision ಆಯ್ತು. ಸೊ ಆ kinetic energy ಅದಕ್ಕೆ ಏನಿತ್ತಲ್ಲ ಅದು ಇಲ್ಲಿ ಹೋಯ್ತು, it goes to the atoms as well as it goes to the lattice, and that kinetic energy will increase the temperature of that conductor. ಅದರ ಟೆಂಪರೇಚರ್ ಹೆಚ್ಚು ಮಾಡ್ತದ್ರಿ. ಹೆನ್ಸ್ ಥರ್ಮಲ್ ಎನರ್ಜಿ ಹೆಚ್ಚಾಗ್ತದೆ. ರೈಟ್, ಆ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಎಲ್ಲಿ ಹೋಗ್ತದಪ್ಪ ಅಂದ್ರೆ ಇಟ್ ಗೆಟ್ಸ್ ಕನ್ವರ್ಟೆಡ್ ಇಂಟು ಹೀಟ್. Right? So thermal energy of the conductor increases. So remember, there is no increase in kinetic energy. Kinetic energy gained by that electrons will be lost in the next collision. Potential energy decreases and thermal energy increases. This is what happens. So first is wrong, second and third are correct. Second and third are correct. Right? So the correct statements they are asking. Okay, we'll move on to the next question. A copper wire of length 1 meter and uniform cross-sectional area 5 into 10 to the power minus 7 meter square carries a current of 1 ampere. Assuming that there are 8 into 10 raised to 28 free electrons per meter cube in copper, how long will it take electron to drift? How long andre they are asking us the time. So ille now I is equal to NEA VD formula ನಾವು ಯೂಸ್ ಮಾಡಬಹುದು. ಇಲ್ಲೇ ನೋಡ್ರಿ, ಈ VD ಅಂತ ನಾವು ಏನ ಡೆರಿವೇಶನ್ ಒಳಗೆ ತಗೊಂಡಿರ್ತೀವಿ, ಬಿಫೋರ್ ರೈಟಿಂಗ್ VD it was L by T, length of the conductor divided by time. So ಈ length ಅಂದ್ರೆ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಅಂತ ತಗೊಂಡು ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಬೈ ಟೈಮ್ ಅಂದ್ರೆ ಡ್ರಿಫ್ಟ್ ವೆಲಾಸಿಟಿ ಅಂತ ಬರೆದಿದ್ವಿ. ಸೊ ನಮಗೆ ಟಿ ಬೇಕಾಗಿತ್ತು. ಸೊ ಟಿ ಇಸ್ ಈಕ್ವಲ್ ಟು NEAL ಡಿವೈಡೆಡ್ ಬೈ I. How much is N? N ಅಂದ್ರೆ ಫ್ರೀ ಎಲೆಕ್ಟ್ರಾನ್ ಡೆನ್ಸಿಟಿ. ಇಟ್ ಇಸ್ 8 into 10 raised to 28 How much is E? 1.6 into 10 to the power minus 19. Minus 19. How much is A? Area ನಿಮಗೆ ಕೊಟ್ಟಿದ್ದಾರೆ 5 into 10 to the power minus 7. 5 into 10 to the power minus 7. Right? Into L ಎಷ್ಟದ 1 meter 1 meter divided by current ಎಷ್ಟದ್ರಿ? How much is the current? Current is 1 ampere. Okay. So 8 5 is 40. 40 into 1.6. 40 into 1.6. So it will be 64. 64 into idu minus 26 ಆಗ್ತದೆ plus 28 ಅಂದ್ರೆ 10 raised to 2. So 64 into 10 raised to 2 or 6.4 into 10 raised to 3. So option D is correct. Option D is correct. Let us move on to the next question. So this is the last question. A wire of resistance 3 ohm is stretched to twice its original length. The resistance of the new wire will be. So resistance R dash equal to N square times of R, we know this. N square, N means it is twice, it is stretched twice. So 2 anta tagobeku. 2 square will be 4, 4 into 3, it will be 12 ohm. Right? So 12 ohm. This is the correct answer. Right? Dear students, hope you understood the questions. And if you need questions beyond 2021, that video has already been uploaded. Please watch that. And if you need the clear-cut concepts for KCET, please go to the playlist and find KCET 2026 Physics. There I have taught the complete second PUC Physics, which is required for KCET in detail. So you can watch those videos and you will get a very good grip on physics and you will score very good in KCET Physics. And dear students, if you like the content of this channel, I request you, please don't forget to subscribe and share the channel. Thank you. Thank you so much. Keep watching and supporting the channel. We'll meet again in the next video. Thank you. This series will be continued.